All right, welcome back. So we left off talking about the equations for the parallel lines model, and now we're going to finally get to this non-parallel lines model, which will prompt us to introduce our first interaction term. So again, we're working with this Wines data set. We did this parallel lines model, and now the goal is to construct a model that allows for non-parallel lines between the two wine types. And so what we're going to do is actually write out the model first and then see why that particular model allows for different intercepts and slopes. And so our non-parallel lines model is going to start out by looking just like the parallel lines model, except now we're going to add this interaction term between chlorides and wine type. And so this is just multiplication. So you're literally multiplying the chlorides with the type indicator. And so this is what we're calling an interaction term. So something that has two predictors multiplied together. And so let's go ahead and write out this model for red and white wine and see why this model allows there to be not only different intercepts between the two types, but also different slopes. And so for white wine, just based on how we defined our indicator, it was a 1 if the wine was white, and so I'll just redefine it up here just so that we could have it on the same page. And so I'm just going to plug in 1 for our type indicator. From here, I'm just going to kind of group together the like terms, so beta naught and beta 2, and beta 1 and beta 3 get grouped together just by the distribution property of algebra or whatever it's called. And so let's compare this model for white wine to the model for red wine. And so again, all I'm doing here is I'm just plugging in 0 for the type indicator, just based on how it was defined up here. All right, so for red wine, that term drops out, that term drops out, and we're just left with beta naught plus beta 1 chlorides plus the error. So we could see now that the intercepts between white and red wines are going to be different because they're going to be different by a factor of beta 2. So if beta 2 is negative, then that means the intercept for white wine would be lower. If it's positive, then that means the intercept for white wine would be higher. And the slope is going to be different because the slope of red wine is going to be beta 1, while the slope of white wine is going to be affected by a factor of beta 3. So either if beta 3 is positive, then the slope for white wine would be more than the slope for red wine. If the slope is negative, or if beta 3 is negative, then the slope for white wine would be less than the slope for red wine. And so we could see here that this non-parallel lines model really does have different intercepts and different slopes for the two types of wine. So what an interaction between a quantitative variable like chlorides and a categorical variable like wine type really means is that white wines can now have a different intercept and a different slope than red wines. Which again, the model, hopefully it's somewhat clear from the way that we constructed it, but it's definitely more clear for most people, I think at least, from the picture. You could see clearly that these red and white wines are going to have different intercepts, and they do have different slopes. And so this also really means just that the association between quality and chlorides, so between our response and the quantitative predictor, is allowed to be different for the two types. So is allowed to be different, more positive, or more negative for white and red wines. And so what's going to kind of represent how different they are, it's that beta 3. So this represents how different the slopes are. Which again, you could kind of see after writing out the two equations, because red wines are going to have a slope of beta 1, white wines are going to have a slope of beta 1, but then adjusted by a factor of beta 3. Okay, so this is getting a little bit more, I think, kind of advanced, but it's also getting a little bit cooler, I think, in that sometimes getting the output from these models can actually be somewhat challenging to interpret, but we're trying to kind of build us the tools, or that's not a phrase, give us the tools to actually be able to interpret some model output that would maybe have this interaction term and have these non-parallel lines, so that we know exactly what each coefficient in the model actually means. So that's what we're going to jump to next, is practicing interpreting some of these coefficients, and so we'll end up using the output for the non-parallel lines model in this wines example.